Hey math fans, we're on section 1.1, day 3. Let's get started. Today we're going to talk about two-way tables and marginal, also conditional distributions. A two-way table really describes looking at two sets of variables, in this case gender, and then whether or not people are thinking that they're going to get rich. It's not really how many columns or how many rows there are, but rather it's two ways of looking at it. Take a look at this data right here. We're going to figure out what are the marginal distributions and what are the conditional distributions. So a marginal distribution is just that. It's found in the margins of the table that you're looking at. You're going to need the row totals, you're going to need the column totals in order to figure these out. And here's how you examine the marginal distributions. You use the data to calculate the distribution in percents, and then make a graph to display the marginal distributions. So right here, we have the marginal distributions of these young adults and chance of getting rich. And as you can see, we are basing this off of the entire marginal distributions always divide by the grand total. And we look at the row or column total. So if I wanted the marginal distribution of almost no chance, well, I come over here, I have 194, almost no chance. This marginal distribution would be divided by that 4,826 to give me a grand total of 4%. 4% believe they have almost no chance. I could also do a marginal distribution of females. What's the marginal distribution? What percent of females were in this study? So I could look at it either way. So marginal distribution, you're taking any one of these numbers in the margin and you're dividing by the grand total. So you're only using these totals. Conditional distribution is different. You need to look at what is the condition. Are we looking at males? Are we looking at females? Are we looking at just the almost no chance or very likely or 50-50? So you really have to read the question. Look for the words given, givens or out of. Those are big kind of key phrases to look for. And again, the same kind of process is involved here, and we'll end up making a graph. We can actually use a side-by-side bar graph or a segmented bar graph, and I'll show you the difference between the two. Using the same data here, it says examine the relationship between gender and opinion, but if I was going to phrase the question, given the fact that the person who responded was male, what percent believe they have almost no chance? Now, the key word is given. That's going to be the number you're dividing by. So given the fact that someone is male, so I'm going to circle that total. That's what we're going to be dividing by. Given that, or out of all the males, what percent believe they have almost no chance? Well, now you go up here to almost no chance. This conditional probability would be 98 divided by that number. So look for that word given or look for out of. You have to find the condition for the conditional probability. I could phrase it in a different way. I could say, given the fact someone believes they have a 50-50% chance of becoming rich, what percentage are female? Well, since it's given, it's a 50-50 chance, I'm going to be dividing by this total for the 50-50 chance. And if I wanted the percentage of female, I would be taking the 696 and then dividing by that row total. And that's how conditional probability works. The hardest thing about conditional probability is finding what the condition is. So read the problem carefully. And then if you take a look down here, we have a segmented bar chart here. And that just means I've taken the different categories, and each of those categories, all of these should add up to, or at least close to 100%. And they're represented here. And we can do some additional analysis. Can we say that there's an association between gender and opinion in the population of young adults? Well, making this determination requires formal inference, which we're going to have to wait a few chapters, but we must use caution. Even a strong association between two categorical variables can be influenced by other lurking variables in the background. Again, that word lurking means there's something else going on that might be explaining what's causing this to happen or getting the results that we are getting. And that's going to do it for this section. We'll see you in class.